I'm a research scientist at Meta. I'm working on large language models from day one. I was working on Galactica project when I arrived. I'm right now working on Llama 3 and from what you have seen as a preview and what's coming soon. Before Meta, I did my PhD in natural language generation, reinforcement learning. And before that, I worked in finance in trading, but that's a previous life.
We have so-called open source models, but I would say it's like open access model and private language model. So the question is, how big is the gap, and what may be the future? How those sort of two competing kind of versions of LLMs might evolve further.
We released Llama 1 year, a few months ago. Llama 2 was not a year ago. It was in July last year. And so before Llama 1, I feel there was zero open source model in terms of pre-training. Before Llama 2, there was neither like zero open source chat aligned instruction following language model open source. So this is actually very, very, very new. And I would say there's a huge boost, increase in number of open source models since then, with Mistral, with Lexa, with even DeepMind is now again getting there a bit with their Llama models. Where we were 1 year ago was like nowhere. Where we are today is close to closed models. Like Llama 3 preview was, it's just a preview, and it was already very strong compared to like GPT-4 even. Which leads me to another thing related to this question about how to evaluate, like what does it mean to be better than other models? Like, and you know, like on the Arena leaderboard, like the LLMs, where like people judge basically two blindly models, the 8 beyond Llama 3 was better than some version of GPT-4. I mean, I'm happy with that, but to be honest, I don't think it's the case. I think GPT-4 is even better than Llama 3 70B. And that also tells us a lot about current state of evaluation, which is partly broken for LLMs. And it's becoming harder and harder to evaluate and to judge what model is better than another one, as we are getting to an area with like general capabilities, from writing a poem to like writing some code or some math, and also to like the other axis, which is expert domain levels, where like models obtains like super high score on laws, on for doctors, for math, for like PhD student level questions, where honestly like the average human will totally fail. That's harder and harder to evaluate them. That tells us also about a bit about the future. I think where we are now, to be very concrete, is we're not yet at GPT-4. Maybe let's wait for the final, not the preview, but the final Llama 3 release. And we say about the future, I don't know, but we will try to make the future more open source.
There's still a gap between like those open access models and more advanced private models, right? Like Claude Opus or
Definitely.
GPT-4.
And our goal is clear, like we will try to get there by the Llama 3.
The goal is to catch up, right?
Yes.
And bring that parity between those.
And I think we're not that far. Very concretely, I think that it's clear that by the end of the year, there will be open source model at the level of GPT-4.
Neeraj has a question.
How much of the gap is in the model, like, in the model implementations versus like the actual training, right? Like just amount of time spent training, or like amount of training data available to the world at large versus compared to, let's say, open.
Tell me if I didn't get your question. Yeah. I feel like every stage of what contributes to the final resulting model, from the data collection, data curation, the way we process it, the way we train the model, the amount of compute we put in terms of weights, but also in terms of what the recipe with the, what is the loss, what is like the learning rate, what are those parameters, and everything contributes to the final gap.
Being open sourced right now is the model definitions, right? Like right now, the model definitions and some checkpoints are what's being open sourced, right? Like, do we still need to make improvements in terms of like, what's actually being open sourced by companies like Meta versus like, frameworks for people to be able to like, combine checkpoints, or like, manage checkpoints produced by like, various people in the community? Like, where's the gap basically? Is the,
I think, it's not publicly available, like what the scale in terms of compute, in terms of size of GPT-4, for instance, or Claude Plus. But I think it's reasonable to say that it's not a 7 TB dense model, and it's more like another order of magnitude of scale in terms of parameters. Arguably, you won't get there without that. Or you change and you have something completely new, a new breakthrough. But it's clear that scaling the current method works, and that you will need to scale by another of magnitude, like the 405 beyond parameters Meta is preparing to get there.
Just to clarify, right? Let's say that I took Llama 3 and I spent, a lot of money just like, collecting training data and paying like, human evaluators and stuff like that. Let's say that I spent an equivalent amount of money to OpenAI in doing that. I would still not be able to achieve the same performance as like GPT-4o or something because the model definition, the model, the actual neural network, like the matrices, the tensors are not are like smaller.
If you take the current recipe with Llama 3, all the training data we have, all the post-training annotation, everything we have done, and you put the same exact modeling than same scale than OpenAI, we have this question: will we reach GPT-4 performance or not? And I guess you will have the answer, or like, are we missing something else? And I guess you'll have the answer by the Llama 3 release. Like we publicly announced that we are training a 405 billion model, and the goal is clearly to get to GPT-4 performance.
Thomas, can you please share more about the training data that you guys use? As I understand, it's a combination of some public sources, of human annotated data and synthetic data.
I think first, like, let's distinguish between pre-training and RLHF, post-training, where like the nature of data is very different. In pre-training, like it's self-supervision. We are taking basically the web. I don't know how much I can say, but like we're not doing anything like secret or specific, to be honest. We're just doing good data, curation, quality, training some classifiers to identify what are the right documents, remove the noise, things like that. Let me say also, because I heard that a lot, we are not using Facebook users' data. Like we are not benefiting from like what we're doing. Basically, anyone else than Facebook could do the same. That is not at Meta. Now for RLHF, I can deep dive more if you want, but we are kind of following the principles we explain in Llama 2 with like scaling RLHF, with human preference basically of like an annotator typing a prompt. We sample from our model two answers. We then ask the annotator which one he prefers. But now we're doing it to another scale, to like much larger diversity of tasks, including expert tasks like math, reasoning, or tool use or things like that. And the resulting basically give us like a reward model plus a series of prompts where we can apply our LLHF algorithm, which kind of result at the end of generating like millions of synthetic data by the model itself, but scored and filtered out from principles by a reward model that distillates the human preference. And then we fine-tune, we align our model with that.
Proportion of synthetic data will be increasing since we're running out of high-quality human data. What kind of challenges have you seen when you were using synthetic data for training?
I haven't seen like challenges per se because of synthetic data. It's working pretty well and pretty efficiently since Llama 2. Maybe like the challenges are for LLHF. I mean, there's like so many challenges, and my intuition, like you can ask follow-up question if you want, but overall, I would say I think we have explored 1% of all what we could do with post-training and LLHF right now.
Are you planning to increase the proportion of synthetic data that you guys using, like for other models in the future? Like, I'm just trying to understand where is it going? What is the trend in the industry?
Right. So definitely increase. Yes, that is clear. No doubt. Now, like it's hard to answer precisely because there's different ways to increase. Like you can increase the number of prompts, which means like the direct synthetic data that will be generated by the model will be increased linearly. But you can also now increase the annotation, and somehow you can see like LHF as a way to train a new generation of model that will generate a new, better synthetic data version. Then you will and do that again and again and again, but you can like drop all the previous synthetic data that were now like obsolete. And so this is also like mean that you can largely improve the final performance with those cycles of synthetic data, and increasing them will definitely help. But the final amount of synthetic data that you use after all this process can almost be the same. I want to disentangle those two aspects, and I think we will still scale both the overall volume of synthetic data that we put in the final model as the number of cycles of refinement and the process to get those synthetic data.
Given we have this discussion about the alignment, I would like to also ask my question. Recently, there was a Microsoft Build conference. Maybe some of you have seen that. And they showed like various tools to build so-called copilots. Stuff where language model is used as an agent that can make some actions. For example, in case of like software development, the action that the agent can run code, can edit files, can run code again, etc., etc., etc. But it seems to me that LLM training kind of lags here a little bit, because RLHF stuff is usually, to the best of my knowledge, based on like, here is the task, give me a response. Like one-step communication, not multi-step communication. How do you think, what are the perspectives of aligning language models to these agent-like scenarios, these multi-turn interactions?
I think, so I'm one of the author of Gaia benchmark, like General AI Assistant. It's like an agentic benchmark now that starts to be popular. It's the beginning of systems that beyond an answer, like what you said as an LLM is limited, we can have this system, these agents that have a memory, a planning component, a refinement, backtracking, and all like what you could expect. And all those components are actually, the cognition of them, the reasoning, are powered by LLMs. And you can see that on the benchmark we released, you can find it on, there's a leaderboard on Hugging Face, Gaia, G-A-I-A. You can see that GPT-4 was like 5% performance. And like recent from Microsoft AutoGen, but also from from a Chinese university Friday, and Hugging Face also published an agent recently. You can go up from like 5 to 40% performance. It's still far from being solved, but we are at a point where those LLMs, without being targeting directly agentic tasks, because they can code, they can understand instructions, they can follow instructions, and things like that, you can actually like tell them something like, now you are a planner, you need to write a plan with like this kind of list, and you can add a lot of things, like if something wrong in the plan happen, like change the plan, adapt, like you can define so many things like that. Or like, and the same LLM powered by that will be the planner, but then you will have like, this is a list of tools you can use. This is a prompt, you need to do like a nested function call to solve your task, like what you do. And this will be like the working memory of the system. And by connecting all those prompts with the same LLM, like with GPT-4 or Llama 3, you can get now some very good results. Actually, I will move to more like agent work like that after Llama 3. I think we're at the beginning of seeing like a large improvement in this field. What the interaction with LLHF and annotation? I say there are two ways. But the way I think about it is, one, obviously you want for the capabilities that are core to agentic, like following instruction, like coding, like tool, zero-shot tool use, all those things, like planning. You want to annotate more, to scale those directions more than maybe like the style of the poem. And on the other hand, it will like enable us to create massive amount of synthetic data that are beyond what an LLM itself, just with its own weights, will have done. And maybe we can like now backpopulate pre-training or post-training with a new level of data beyond what the LLM itself will have done. And that's also like back to the previous question, like about synthetic data, a very promising direction to like scale synthetic data.
Why do you think it's not happening like right now by OpenAI or Anthropic or Meta or some other big companies? With this synthetic agentic data, or it's too early maybe for this?
We're seeing the sparks of that somehow. Is it happening? Is it not happening at OpenAI on Anthropic? I can't comment. Honestly, I just don't know. At Meta, we're starting to... Sorry?
I mean publicly. I also don't have some insider information.
Yeah, I will argue though that even on OpenAI ChatGPT, you can actually now ask questions like for math or things like that. It will actually write a code, execute it based on the execution, answer your question, or like browse information.
I'm not saying that the current models cannot do that. I'm arguing that they probably will do better if aligning them additionally for these tasks. And I'm kind of asking, why isn't it happening right now really actively?
I'm sure OpenAI is aligning toward that, to be honest. And on our hand, like we are for the math retargeting some of these like primitive tasks, just the very, very beginning of that. But of course, we'll start to focus more now. My intuition is, in terms of research, is to move to this kind of agentic task, you need to solve first language modeling, including like pre-training, alignment, RLHF, instruction following. And now that we have not solved it, of course, it will increase and improve over time, but with incremental gains, we have now cognition system that can empower like those systems. And this is, so first you need to work on those kind of things. And we are close to like GPT-4 levels with open source model as discussed before. So only now actually we can start working on that.
Question about, super alignment. These days, lots of conversations about it, and it seems like there are two camps. Like alarmists say like, oh, it's already too late. We have to, move very fast and be worried more about super alignment and put more efforts and resources to that. Another camp says it's too early and we still don't know how those AI systems will evolve. I'm wondering what is your approach to super alignment and basically how you guys internally, kind of think about super alignment, and especially when you work with, when you train Llama models.
It's not clear to me what exactly is super alignment versus alignment, to be honest. I don't like the superlative terms in general. There's different questions here. Like, what is the strategy to get this technology safer? From that perspective, in general, the public scrutiny, transparency had shaped better the technology in the past. Now, there's another thing also that I didn't like much in this overall discussion. Even if you believe like you have this PDOM thing, which would be very important with LLMs, I think what is missing from the discussion is what's the PDOM of everything in the world, like not just AI, because the PDOM of like, I don't know, a nuclear war or a bacteriological war or like the problem we have with the ecological problems. I think if you think about everything like PDOM, well, maybe AI is not that bad, and actually maybe it can even like, even if it had a PDOM, which I'm not totally certain, to be honest, it means also that it has such a trendemus potential that it could actually shape the probabilities of like doom of any other things so much that it might actually be quite significantly better. And if you now believe from this perspective, you want to accelerate the development of AI. And what has been the main driver in terms of progress for AI in the last decade? I think it's open source. I think if Transformers hasn't been like published as a paper by Google, even at Google, they will not have understood it's a good paper. Right now at Google, I'm pretty sure they will still use LSTMs. If we want to keep accelerating, and we think this technology has some large potential for humanity, I don't think it's the right way to like be in this kind of things of closed source, open source is decreasing everything itself. Now, that being said, it doesn't mean we don't have to think about alignment, all these questions in advance. And I think this is very nice to see, for instance, Anthropic and OpenAI to lead this research in advance.
Do you think we should keep pushing these open source models and give opportunity to community to contribute? And once we see it's dangerous, kind of change the policy? Or I understand it's a little bit speculative question, but I just wanted us to kind of think about it together.
We should regulate it. We should think about it like in a way that is like useful for everyone. We should keep open sourcing and giving this technology to people and to developers and kind of that. But we can actually develop some framework to like, just like for like vaccines. We have like framework to test them at scale. We have some metrics like is it fine to release it or not fine yet? Did we do enough tests? So developing this kind of framework of testing is, I think, a good way to think about it. Anticipating the risks, like cybersecurity risk or whatever it would be. Thinking about that is something I think is good. But instead of like saying we should not do at all anything there, it's too risky. I think we should, and we should also think about what are the risks and try to anticipate them as much as possible.
Gleb, yeah, go ahead.
How do you see the situation in terms of understanding the black box behavior of large language models? Like we don't see much of research related to interpretability of the models, like how the knowledge is located inside. Luckily, like last year, more and more of them do appear, but still, like how would you assess our knowledge about the intrinsic structure of the models and how to optimize it, how to deal with it, and stuff like that?
Are you referring, like, for instance, to the recent work of Anthropic on like mechanistic intervality and those things?
For instance, yeah, that may be an example.
I will not be like very long on this question just because I don't know a lot. That's not my expertise at all. I saw some works for Llama 2, like showing some temporal noise structure, playing with like modifying a weight, things like that. I think there's quite some, I mean, at least that's a good thing about open source model. People can actually do that, play with that. And for like academia that is often GPU poor, there's a lot of research that can be done there, which will be very important. So that's great. Now, I think this direction and what Anthropic shown in the paper is super exciting. I think it will also, because it was like it start to work kind of. I'm expecting more and more people to work on these kind of things in the next months. But on my side, I don't have a lot of conviction or anything. I'm just not knowledgeable enough.
So I see there's another question from the community. So are we into scaling mostly today? Basically, throw more compute, more data, increase the parameters of the model, and get like sort of smarter AI systems. Do you think it's the only way to keep improving AI systems? What is there like any streams of more low-level algorithmic research or like exploring other ways how to develop intelligent systems without necessarily to throw more compute on it?
I won't be serious if I would say like it's the only way. I just don't know. But I clearly think it's one of the way, definitely. I kind of think about that, to be honest, as like a triangle. I had this discussion with a colleague from OpenAI at iClear last month, and we were thinking like about that as a triangle with one hand is compute. The more compute you throw there, the better it will result. And we haven't seen any plateau of this kind of laws yet. But the other angle of a triangle is data. Maybe we can create data, we can create better data, we can annotate better data. And scaling that dimension is always a good way to get there. And the last one is like people, research scientists, things like that. And you can find new, better algorithms that are just scaling better or requires less compute to get to the same performance, or to actually improve the data with some scripts and some filtering. I feel like at the end of the way, you have this vehicle that can get to some amount of intelligence with more compute, better data, or just a better vehicle thanks to new algorithms.
Do you know if there is also some research happening, like for example, when transformers were introduced, it sort of like really changed the landscape, right? Right now, it's all about transformers. Do you see, is there like any alternative research, like on algorithmic level is happening that can also bring the same boost in the future? I mean, or like everyone is now like thinking about only how to optimize transformers?
Yeah, so I think they're like, for instance, state-space model, SSM, without like to play with the attention mechanism. There was like kind of these Mamba things and all those models in the recent months. I'm not sure how good it will end, but there's definitely some research on that. But Then the other thing is mixture of experts will definitely be part of the game in the future. And that's another way to still like leverage basic transformers architecture, but have a new dimension to optimize for scaling with like the experts. Even if we stay with transformers, and I don't know, like we can find new algorithms or whatever, we can play with the attentions, we can play with the experts, we can play with all those new dimensions that will add and compound to scale better. So I definitely think it's not the end of like, we should not stay with a Llama architecture in the future, just scaling that.
Actually, this is a question, you mentioned the triangle and like, part of the triangle was data and people. Who's building those tools? Like, it seems to me like the biggest advantage that the world has relative to OpenAI or like, whoever else is like, whichever private companies are training models is exactly that, like, billions of people can gather data much larger data sets and create much more high quality data sets than like, than these corporations. But what are the projects that we should be looking at? Like, if we actually want to contribute to something like this or do something like this, like, who's doing that work?
Maybe someone is doing it. I don't know. But that's definitely a very, very fair point. And we were like thinking internally, like someone should build this kind of like Wikipedia of annotation with like expert levels, skills there. Like it's probably very tricky to build like as a community. And the first reaction will be, yeah, but people will add some noise or thing like that. That's what people said at the beginning of Wikipedia, and how it results today is incredible. I think there's definitely something to do there. Definitely. I don't know what. We had this kind of random idea about a Wikipedia of annotation, for instance, on post-training. But I definitely think there's something to do at some point.
Do you think it requires the support of some corporation like Meta because of the infrastructure requirements, like hosting all that data and stuff like that, or could it be more decentralized?
I think it could be decentralized. I'm sure like Meta will be happy to support it, to help or whatever. I don't think like Meta should be like, for instance, the one that drives the effort. There's some companies or non-profit that would be better positioned probably, but I'm sure Meta will be happy to contribute and to support such efforts.
Do small research-oriented companies without crazy funding have any chance to deliver value these days?
I think definitely. Look, like DPO was the best paper at NeurIPS, like a new alignment algorithm. It was done with few resources and at I think it was Stanford. I don't remember which university. That's one example, but another like concrete example in terms of companies, Devin with the cognition company, they raised like a lot of money, but they had the demo that managed to raise the money before with not a lot of resources, playing with open source models or like few thousand of dollars on GPT API and building the tools to get to the next level of basically code fixing, code automation. So I definitely think there's a lot of space. I just think like people should choose their battle. Of course, you don't want to train the new state-of-the-art pre-trained model without resources. That doesn't make any sense. But doesn't mean like there's no opportunity. There's actually plenty of opportunities, I think.
I see there's a question about hallucinations. What is the current state of things, and what kind of mechanism do you guys use to reduce the hallucinations in LLMs?
I can't say a lot. I'm actually working hands-on on that right now, but I promise we will give some details in the paper.
In terms of like Llama models, like what we should expect in the future, what is the kind of vision? Like how do you guys see like future, evolution of these models?
Meta now is clearly bullish on AGI, and Llama is a vehicle to get there. That's the goal and the direction. Now, how to execute that? Clearly, we will scale what we have right now. We'll also explore again, like to new ways to scale better. Either some breakthrough in the open source community or just some incremental novelty, we'll integrate that as well. The path is kind of clear and unclear at the same time. For instance, like, thinking about agents, do you want to, or like the current version of agents are very, very primitive with like a huge LLMs that is called multiple times for planning, for working memory. It's clearly inefficient. It might be the way to get to the next level to create some of those smart data that will be enabled to train a new family of very small model, more efficient. I don't know. That's open research question and research direction we'll work on. But the goal is to get smarter models, better models in all capabilities that can actually help people as like, I don't know, personal assistant for everyone, better on any capability than the average human, things like that.
You mentioned about AGI, and it's clearly something that you deeply care about, or like sort of working towards that. At the same time, they're like, not clear definition. What is AGI? What should be considered AGI? What is the threshold? I'm just wondering, in your opinion, how you would define AGI, right? And how do you see the coexistence of humans and AGI?
I think the main definition is like doing more than 50% of economical valued tasks in the world, which is a moving target, to be fair. I think there's a lot of definitions. I will put two thresholds here. One is, and that was the spirit of the Gaia benchmark, doing any tasks that the average human will do well. So those tasks can take like 1 month of work and require like millions of steps to get there. But if you give it with enough time to any human, and almost everyone will get there. I think that's the first kind of level of AGI we'll get. And I think we're not that far, but there's still a lot of work to get there. I'm confident we'll get there by maybe this decade. Now, what's next is kind of this singularity moment where everything accelerates, the AI self-replicate, accelerates science and all those things. That may not be science fiction, but I just don't know. It's too far.
There's so many unknowns, right? So we
exactly.
can't really
I'll be happy to get to the first thing done, and we all have like a Jarvis in our pocket.
Yeah, basically the nearest goal is to have this personal AI, like smart personal AI assistants. That's the sort of the first milestone to hit.
Yeah.
Okay, understood.
And I don't see how we can get to the next one without that, to be honest.
Yeah, after we get to the first milestone, then we'll be clearly how to get to the next one. Understood. Okay. Questions regarding the career. So basically, if someone doesn't have some like super crazy impressive resume, but they do want to work in a cool AI company, just sending resumes and like interacting with HRs almost never works. Like, do you have any advice on like if someone wants to get into AI research, what should steps be?
I think, let's be honest, if you don't have a very good resume, you will not pass the bar of the recruiters. That's clear. Now, what's a good resume? That's where it gets interesting, because sure, like good schools can get you there. Not necessarily, like now the bar is even higher and you need some papers for research. Yet, like, if you like do an open source project, you're known for anything that gets like, that show basically that you can do this kind of research, that can get you there as well, actually, and even maybe more clearly than just a diploma. So I think there are just different ways to show off on a resume, and not only very like Ivy schools level. And that's more and more true than ever now. So sure, like if you're smart, but you haven't done this project, you haven't done a school, yeah, you won't pass the bar, like let's not lie. But if you want to commit enough and to spend some time to develop a first project, to join like an open project and to contribute there and to become one of the main contributor, and that you can show that might be enough.
I'm wondering, like, what kind of skills people should have to pass the bar? Basically, what guys you are looking for when you're hiring someone?
Yeah, there's different roles, and I don't think like all my colleagues will answer the same way I do. On my side, and it's not the same like if you're like a software engineer or a research scientist or things. Like for instance, on research scientist, what I in general ask is like some high-level perspective on the field, understanding like where we are now, where we are going in terms of directions, what are the current limits and trends. But also like, for instance, the kind of question I ask is like, what's your last paper? And then, or read my last paper and find the weakness, find what's wrong there, find what we could get better. So like to show like a deep understanding of what are the limitations, how we could improve. That's a way to measure like if a research scientist have some sense of critique of anything like that. For software engineer, of course, like you want to like very good coding skills, but also like from typing codes to like conceptual.
If someone is a complete novice in LLM, but they have strong math background, what resources would you recommend them to, to use to get more proficient in building training LLMs?
Right. Honestly, I don't know because I never get to that. I know there's like plenty of them. Which one are good or not? I heard a lot of good things about Karpati video on YouTube or code like to learn like nano GPT and things like that. There's probably a lot of others. I'd say like the question is not maybe the resource, but more what you want to do. Like understand LLMs, train them at small scale to understand how it works, what are the parameters, how like then find a resource, understand like what about it, then move to another one that teach you new things and like learn more and more and more new things that way. There's some resources also for like I remember when I kind of learned, I started with Andrew NG lessons on deep learning. It was good. At some point, I preferred to move to like some blog post about some other stuff to get deep dives, then go back to some general. So it probably depends on everyone, to be honest.